The next example addresses vector components with just a flavor of forces. In this situation, a force of 12 newtons is being applied at an angle of 36 degrees to a 14 kilogram block. The question is what mystery second force, when applied, would create an acceleration of 0.4 meters per second squared in the x direction only. Since the initial force on its own would cause an acceleration in both the x and y direction, I know there must be a second force at work. Now, because the force and acceleration have been mentioned, hopefully your brain has triggered F net equals ma. So now we can go ahead and figure out what our net force needs to be with the information given. A mass of 14 kilograms accelerating at 0.4 meters per second squared in the x direction requires a force of 5.6 newtons in the x direction. It is worth noting that the direction carried through the multiplication there. A handy trick about Cartesian coordinates is that I can consider x and y components separately from each other. Since more than one vector is at work, we will consider the sum of forces in x and the sum of forces in y. Since there is no y acceleration, I know my net force in y will be 0. And we already found that the net force in the x direction is 5.6 newtons. In order to determine the magnitude and direction of the second force, it will be easiest if we first decompose the initial vector into its x and y components. So force 1x is adjacent to the angle, so that would be F1 cosine theta, or 12 newtons cosine 36 degrees. And using a calculator, I get 9.7 newtons. F1y is opposite the angle, so if I draw the y vector there to complete the triangle, F1 sine theta equals 12 newtons sine 36 degrees. And I get 7.05 newtons. Since the sum of forces in y is 0, this makes the y component solution really easy. If F1y is 7.05 newtons, then F2y must be exactly opposite that. I know my sum of forces in y is 0, and that y1 plus y2 equals 0. Thus F2y equals negative 7.05 newtons, or 7.05 newtons pointed in the negative y direction. Similarly, for F2x, the sum of forces in x is 5.6 newtons, which would be F1x plus F2x. 5.6 newtons equals 9.7 newtons plus F2x. And if I solve this for F2x, I get F2x equals negative 4.1 newtons. So I can draw that vector component in the F2x direction. And if I wanted to draw the resultant vector, I can take these two vectors and add them together to get my F2.